Hi friends, welcome back. Naji here. So in this video, we will be discussing on embeddings. Okay, so first let's understand what is an embedding. So embedding is something that convert words or text into a list of numbers that capture its meaning. And for example, here I have given a word king and its embedding representation may be something like this. Okay, so these values may change based on the embedding model that we have selected. Okay, for example, if my embedding model is embedding model size is 784, okay, then the embedding size will be 784. So if it is 1024, it will be like 780 1024. Okay, and its also value also will be different. Okay, but just to say, or for the example, I'm just taking, okay, if the word is king, then the embedding will be something like this. Okay, then consider to understand it better, like consider like if we have a geo coordinates of two places, say like A and B. So if I have a geo coordinates of two places, I know that exactly I can do I can calculate the distance between these two locations, right? And I can conclude that okay, these are like very close to each other, or these are away from these are far away from each other. All those things that I can understand, right? Similar to that, if I have a embedding of two words, okay, or two sentences, I can actually combine, I can do similar kind of operation. Like I can see that okay, these two sentences or words are close to each other, or they are very far away from each other. So those kind of a meaning, or this kind of a property I can bring when I have the embeddings in my hand. Okay, now why do we need embeddings? Okay, the solution is, the answer is very simple, right? Everybody knows that from their childhood, and computers only understand numbers, not words. So that is the only reason we have the embeddings in hand. Okay. And definitely it has to have, the embedding has to have some kind of a meaning, right? I cannot give like king is equal to 1, queen is equal to 2, and something like this we cannot give, right? Because it has to have some kind of meaning. It doesn't mean that just 1 2 3 4 numbers. Okay, now let's go to the next slide. Okay, and we can understand how embeddings are created. Okay, so in a high level, I'm not talking about the technical aspect of it, but I'm just talking in a high level. So high level, we will have a lot of data will be there. So we will be passing that into a neural network, and the AI learns, the LLM model learns from it. Okay, so based on that, it will have some kind of a context understanding of these meanings. Okay, for example, after the training, if you give like a cat and dog, then they will have a similar embeddings because they both are animals, right? And if you have like a car and truck, because that is also like a kind of like a very close to each other. If I draw that in a graph, the car and truck will be close to each other because they are like machines, right? We can say. So if it like a cat and dog, they are animals. So these groups are little far from each other because one is animal and other is a vehicle category. Okay, so that is the use of or that is how we train the embedding models, and this is the use of embedding models. Okay, now let's go to the next slide. Okay, then based on this embedding models, what all things that we can do? Okay, so I said that I can check the similarity, or the how I can say that okay, how close these words or sentences are, how far these sentences are, right? So for that, one of the operations that we do is the dot product. So in a dot product, what we will do, we will have two list of numbers will be there, and we will do some multiplication, then we will have a single number. Okay, so that is what we call the dot product. So for example, if you have a dot b is there, then we will take like a1 into b1 plus a2 into b2 plus a3 into b3, then we will have a single number will be there. For example, consider we have the vector here, vector a 2 3 4 and vector b 104 102, right? And if you calculate this, I get like a positive number 10. Okay, which means these are close to each other. Okay, and for example, if vector b is like -1 and 0 and -2, then the number is like a very low, or it will go to the negative side. So from that I know that okay, how close or how far are these two vectors. Okay, so this is the one way of doing that. So just to example, I can just do a calculation here. We know that it's a 32 is the answer, like 1 2 3 4 5 6, answer is 32. Okay, so larger dot product equal to vector points is similar direction, the words are related. For example, if I am giving this -1 and minus c, and let's do the calculation. Now I am getting a minus 12. So which means these two vectors are far away from each other. Okay, so in this kind of a calculation, so we can do when we do the dot product. Then another scenario, that is, or another the term that we can see is the cosine similarity. So in the cosine similarity, we are checking the angle between two vectors, so which is ranges from -1 to 1. For example, I have a vector 1 is there and I have a vector b is there. I am checking the angle between them. Okay, so what is the use of it? Okay, so if these two vectors are very close, then the angle theta will be very small. Okay, and if the angle is too high, for example, the vector b is here, and I can say that the theta is 180 degree, so which means the angle is too big, and we can definitely be able to say that okay, these two words or sentence are the opposite directions. Okay, and this is how we calculate the similarity score. Okay, we can the cosine similarity, I can do that a dot b divided by modulus of a into modulus of b. Okay, so we don't need to remember this. The frameworks is also providing very easily with some functions we can easily calculate that. So I'm just giving you this information for the sake of understanding. Okay, so if you see that if the value is 0, I can say that same direction and very similar. If it is 0.5, we can say that okay, it is somewhat similar, and if it is -1, we can say that both are in the opposite direction. Okay, now here understand the dot product and the cosine similarity. So there may be always have a question, okay, which one that we need to select? Do we need to select dot product or do we need to select the cosine similarity? And we can see if the dot product that we are using, we are actually looking at the direction and the magnitude. The value is also important. So in my previous example, we can say that just 35 is there, 120 is there. So it's only giving the direction, it's also giving kind of a magnitude also. But in the cosine similarity, it does not give us the magnitude, it is only giving us a direction. So I can say that two words are going in a similar direction. I don't know like how its magnitude is, right? I can say that okay, if the theta is like very small, I can say they are in the same direction, or if it is away, I can say that okay, they are both going in a different direction, right? And in the dot product is minus infinity to plus infinity is the value range, and cosine similarity is -1 to +1. And this is affected by length, yes, and it is not, because it is normalized. Okay, best for when the magnitude matters, and it is best for the comparing similarity. Okay, I will show you with an example here. Consider this particular example, vector a. Vector a, that is 2 and 3. Okay, then we have a vector b, which is 4 and 6. Okay, so here we can see these both are the same, right? If we multiply by 2, we will get 4. Here multiply by 2, we will get 6. Okay, so if you do the dot product, then value is 26. Okay, so which means it is a same direction, but its magnitude is 26. But if you do the cosine similarity, it's actually 1. Okay, because they are both in the same direction and they are both in very close. So cosine similarity give us only the magnitude, I mean only the direction. Okay, it does not give us any magnitude. So that is one point I need to discuss. Then some of the real world use cases, we can use this for semantic search, chatbot, recommendation, text classification, translation, and rack system that we can use. Okay. Okay, now we can go and see how this can be do in Vertex AI. So till now I have been discussing about in a general way what is a embeddings and all those things, but now we can see how this can be implemented in the Vertex AI. For that, let me open my Visual Studio Code. So let's open it. Okay, so I have my Visual Studio Code is there, and this is the code that I copy and paste from our previous tutorial. Okay, so I have explained about how to create the key, and all those things are we have discussed in our last class. So I'm not going to discuss that in this tutorial, but that will take another 10-20 minutes. Okay, so we have our initial setup is ready. Then now we can see from the available embeddings in Vertex AI. Okay, so for that I just did a search for that, and these are the currently available embedding models. in Gemini. Here we can see Gemini embedding 001, and its dimension is we can say like a 3078, and the maximum sequence length is 2048, and it is supported the text languages only. And here we can see text embedding 005, and it's actually supporting the English, and here we can see it's a specialized in multi languages. Okay, the text multilingual embedding 005 will help us for the multilingual support. So if you want to use the multilingual, then we have to use a multilingual embedding has to be used. Now we'll see how can we initialize this and how can we use in our programs. For that, what I'm going to do, I'm first going to import few things. I can import from Vertex AI dot language model. I can import text embedding. Here we can see text embedding model. Okay, now I'm going to select embedding model, and I can say text embedding model dot get embedding. Here we will be using the text embedding. I can say text embedding 005 is the embedding that I am going to use. Okay, so I'm getting some error. Let me check that. Get, maybe it's because of single quotes, I'm not sure. No, it's text embedding model. Okay, so I need to have it from pre-trained. Let's execute it. Text embedding model is not found. Maybe let me check this spelling. It is wrong. It is embedding is there. Text embedding 005. Let me execute it again. Okay, so here, yeah, now it is working fine. Now I can check like em1. Okay, I'm going to create a embedding, so that is very easy. I can say embedding dot get embedding. Here I'm going to say apple. Okay, so this is my embedding 1, and the next is I'm going to take a em2. Here I can say em model dot get embeddings. Now I can say the car, or car, just car, and this is the em2. Now if I want to see the length of the em1, here I can see this is the length of em1. Okay, and if I want to see the embedding, then I can check that em1 0 dot values. Okay, so here I can see the text embedding. Okay, so if I want to see the length of the dimension, I can check length of values. So here we can see it is 768. 768 is the dimension of this embedding model. Okay, so that is why we are getting the 768. So let me go back to the here we can see it is 768, right? We are using this one, text embedding 005, and its dimension is 760. Output dimension is 768. Now what we can do, we can try to see how close these two words are. That we can check. So there are two options that we have discussed, right? One we have discussed is the dot product, and another is we discussed about the cosine similarity. So let's understand with the dot product first. For that I'm importing the numpy as np. Okay, so numpy is providing the details. I mean numpy is providing the necessary packages for the to calculate the dot product, to do the dot product calculation. For that, what I can do, I can take em1 dot values. I can convert this into the np array, and I can take here em1 dot 0 dot values. Okay, so this is the one value. Now em2 dot values I can take, here I can say np dot array em2 dot 0 dot values. We are converting this into the numpy array. So we have two things are there, but somehow I'm not getting em1. Something is wrong here. Let me check. what is em1, em2, em2 dot values not append, it is em dot array. That is the reason. Okay, now I can simply do a calculation using the dot product. Okay, so for that I can do np dot dot np dot dot. I can calculate em1 underscore values, em2 underscore values. I can see how similar these words are. So we can see they are difference by 0.61. Okay, so that is their number. And let me put apple, then I can put a maybe orange here. Now let's execute it. We can see their similarity. Okay. Here we can see their similarity to 0.68. Okay. Now let me run it again. Okay, now I can take the two sentences, then we can see how close these are. So the context is more relevant when we have a sentence. I'm saying that I love to eat apple. Here I'm saying I love to eat orange. Okay, now let's see the dot product between these two numbers. Here we can see it says about 0.775, so they are kind of a similar. Now I'm saying that I love to drive a car. Okay, so this is my second sentences. Now let me execute this. See, so here we can see that when we do the dot product, its value is reduced, right? Earlier it was 0.75 or similar to that. Now it is reduced to 0.58 because these two are different statement. Now here I can say I love to eat, I can say apple only. Then we can see, like, if I have the same sentences, we can see how much similar these two are. Okay, see, now if the sentences are very close, I am getting almost 100% match. Okay, so in this way embedding can be used to like different manipulations. Okay, so this is very important to understand when we do the RAG application. So that's why I explained its basics and the two dot product and the Cosine similarity also in a detailed way, because this is really helpful when we do the RAG application. So that is all about in this video. Please do like and subscribe. Have a nice day. Bye bye.